Hi students, welcome to We Karnataka KCT and Boards. I am Diksha Kaushal, your chemistry master teacher. So hi everyone, how are you all and how's your preparation going on? I hope so that's really going well. And today we are going to talk about a very interesting and a very important topic, that is your naming reactions for your midterms. I am going to pick up naming reactions from your chapters haloalkanes, hydrocarbons, haloalkanes, haloarenes, alcohol, phenol, ether, and aldehyde ketones and carboxylic acid, right? So the naming reactions are difficult because they will give you a single name and they will ask you that what is the reagent, what is the product, right? So they can play with the questions of naming reactions a lot, right? So why we are studying naming reactions as differently, right? This chapter has these many naming reactions. So instead of that, let's carefully see all the naming reactions that are here, right, in today's class, right? So are you all excited for today's class? So wait a minute, let me show you that what are the naming reactions. Yes, everybody, namaskara. So students, as you can see, these are the list of naming reactions, right? Finkelstein, Wurtz, Darzens, Sandmeyer, Gattermann, Wurtz, Fittig reactions, Dow's process, Lucas, Williamson synthesis, Etards, ma'am, the names are really tough. Kolbe reaction, Riemer-Tiemann, Gattermann, Williamson, Wolf-Kishner, Aldol, and Cannizzaro, Helvohard-Zelensky reaction, HVZ reaction it is pronounced. Rosenmund and Stephen reaction. So, right, I know the names are tough, and to understand the reactant, the reagent and the product, right, to remember that is even difficult, right? So, we will try to remember everything with the help of some stories, some tricks, right? And the notes are my handwritten notes, right? So, it's not a bookish thing that I have copy pasted, right? I have written it myself, right, for you guys, right? So that you can remember this in the exam, because I know when you write the notes yourself, right, that will stay in your head for a longer time. Now, I just need one thing from you, right? And what is that thing? Very good evening, very good evening. So, Devesh, I'll let you know on the Telegram channel, okay? Yes. So, now, let us start with your ma'am's handwritten notes, and these will be available to you, right? These notes will be available to you on the Telegram channel itself, right? Okay. This is our We Karnataka KCT and Boards Telegram channel. The link is in the description. You can join that, right? So let us start the very first reaction. I want everyone, you will definitely get your notes here, but I would advise you, after going through the notes, now just try to understand. Now do not write it, right? Now the first promise is, do not write it down in the notebook and then, ma'am, yes, you are speaking, we are writing, you are speaking, you are writing. You have been doing this in school, right? You have been doing this in school. That's why now you don't remember anything. Right now, just focus on what I am saying. Just focus on the tricks. Just focus on how to remember this reaction, the reagent and the product. Rest of the things, notes will be available to you. You can go through those notes and make your own separate notebook where write down in your own handwriting, in your own tricks, write down the naming reaction and revise it daily, right? And I assure you that you will not even, there will not even a single negative mark set you will lose from the naming reaction. That I can guarantee, right? Okay. So now, first reaction is Finkelstein and Wurtz reaction. So basically, these two reactions are for halogen exchange reactions. Okay. What kind of reactions are they? There are halogen exchange reaction, right? Halogen exchange reaction. Finkelstein and Wurtz reaction are your halogen exchange. For example, you will have one halogen, you will have an alkyl halide. From that, you are making a new alkyl halide. That is halogen exchange. You are basically exchanging that halogen, right? You are exchanging that halogen, right? So now you basically have two kind of reaction. One is Finkelstein, other is Wurtz. Now, how will we remember this, right? So, we will remember this by Finn and Swati. So, there was this Roxa. Roxa is our main heroine, right? She is our main heroine. So Roxa is like, oh my god, Finn is like a boy who is following her, right? So Finn is like, hey Roxa, you know what is acetone? Acetone is nail paint, no? Nail paint, right? So Finn is like, Roxa, you will look more pretty if you apply that acetone, if you apply that nail paint. Nail, N-E, nail paint, right? Nail paint is what? Nail paint is made up of acetone only, right? Isn't it? So, Finn said Roxa, Finn was like, Roxa, you should be more, classy, fashionable. Why don't you apply very beautiful nail paints, acetone, nail paints, right? Then Roxa will be like, I don't want to do this. No. I don't want to do this, right? So, by this, I think you remember the reagents, right? Roxa, Finn is asking Roxa to apply nail paint, N-A-I, nail paint, and nail paint is what? Acetone. It is made up of acetone, CH3, right? Okay. Now, what you have to do, you just have to exchange the halogen here. Now, this I is the halogen, this X is the halogen, and this will be replaced by this X. Right? So here you will have the formation of Ri and this is your NaX. Very simple, right? Very simple, right? And now next thing is the main important key points I have written on the side, right? That is, it is not shown by your aromatic halides. Aromatic halides will not show any Finkelstein reaction, any halogen exchange reaction is not shown by aromatic halides. What are, ma'am, aromatic halides? For example, you have a benzene, on this you have a chlorine. For that we have different reactions, right? Finkelstein is only applied on alkyl halide, not on aromatic halide. I think that is clear to everyone here, right? Be active, guys, in the chat box, right? Be active. Now next is NaX. That means they are saying the NaX that has been precipitated out here is precipitated by dry acetone. Now, what is the use of this acetone here? It will pip it out, it will take out, it will make the precipitates of this NaX so that we can get a very pure Ri. We can get a pure alkyl iodide. For example, you have a beaker. In that beaker, you have a lot of mixture of products, right? Which are totally mixed to each other. In that way, it is difficult to separate them out. But now in a beaker, one is already precipitated, one is already sitting down, doing nothing, right? So it will be easy to separate these two things out, right? That is why acetone is here, right? Hello students, hello, Arjun, Rishabh, Kumar, Prabhu, Rajesh. Yes students, hello, Srinivas, hello, yes. So now, next is, Acha, do let me know in the chat box, are you able to understand these things or not, right? So next is your Swartz. Now, with the same Roxa just ignored Finn. Like, girls always what they do, they ignore the boys, right? But they will always listen to their best friend, right? So Roxa ignored Finn, right? This you have seen in your daily life. But Roxa will not be able to ignore Swati. Now, here you have Swati. Now, Swati will say, Roxa, why don't you wear some good silver rings, silver chain? Get some fashion in your life. Why are you so boring, Roxa? Then Roxa will be like, okay, she wants me to be fashionable. F for fluorine, F for fashionable, right? So now Roxa here, Roxa is not fashionable. Finn, she just ignored Finn. But here Roxa is very fashionable because she will listen to her best friend Swati. Right, so basically what happened, this is just a way of, so that you're able to recall these things in the exam hall, right? Now, here as you can see, you have Rx and that X, that halogen can be a chlorine or bromine, right? It cannot be iodine, it cannot be fluorine, right? It can only be chlorine and bromine. Now, you will have some transition metal fluorides. What kind of fluorides? Transition metal fluoride. Now, those fluorides can be AgF, it can be Ag2F2, it can be COF2, all are transition metals, right? SbF3, right? So, it can be any of these can be there, right? And those metallic fluorides will be used, right? For the formation of RF. Now, directly the formation of RF, it's very explosive in nature, right? That is why fluorine is very explosive, very exothermic reactions will be there. That is why it is difficult to make fluorides. Now, tell me why it is difficult to make iodides. Iodides, it is difficult to make because it is a very slow and reversible process, right? That is why we have a specific naming reactions for Finkelstein, for halogen, for Ri and Rf, that is Finkelstein and Schwarz reaction. Third reaction is different from these. Now we have done halogen exchange reactions, right? Two of them we have done that. Now next is your Darzens. Okay, have you seen that movie Tarzan? How many of you have seen that movie Tarzan? So in that Darzens reaction, what exactly will happen here? Here you will have ROH, right? One person, you can think, one person has drank alcohol, right? And that alcohol, now he has to remove that alcohol out of his head, right? So it will drink some soda. Be like, man, we will never forget this reaction. Now, Darzens, there was a person Darzens, right? He drank a lot of alcohol, right? OH means alcohol, right? So he drank a lot of alcohol. He wanted that I want to get this alcohol out of my system. So what will he do? He will drink some soda. Soda means SOCl2. Basically, soda means this SOCl2 means your thionyl chloride, right? This is nothing but your thionyl chloride, right? This is your thionyl chloride. But here what I am saying, alcohol. He will drink alcohol and then he want to drink some soda so that he can get that alcohol out of his head and form RCl, right? And form RCl, because from this Cl, it will be replaced here and it will have the formation of RCl here, right? And these two, SO2 and HCl, are the gaseous products. So that is why it is easy to have this pure RCl, right? Because these are already gaseous. They will become and they will like fly in the air, right? They will fly, right? There will be no SO2, HCl in the beaker itself. So it is easy to obtain pure RCl here, right? Okay, students? Simple? Yes, everybody. Simple, simple, simple. Next is Wurtz reaction. Wurtz reaction, Wurtz-Fittig reaction, very simple, right? Very simple. Now let us see how this happens. Wurtz reaction, right? Wurtz reaction, what will happen? You will have one Rx, you will have another Rx, right? This X will go, beta. What is an X? Who is an X? Who is an X? X, we all want that X should go from our life. Or do you want X to stay in your life? Yes, ma'am, we have language. Oh, okay, Suhas. Then you can see the recorded version, right? When you have your chemistry, you can see the recorded version. That's the best thing about YouTube, right? You have the recordings there, right? So now, see this thing, Wurtz reaction. Let's talk about what you want your X to go from your life or to come in your life. You want your X to go, right? Everybody wants to, everybody wants that X should not be in their life because X is going to make our life very toxic. So this also, Roxa also wants that X should go from my life. I want to be alone. I don't want any X to be there in my life. So what it will do, it will take the help of sodium, right? So sodium in the presence of dry ether will help Roxa to forget about, to totally just have no X in her life. So this is your Rx, this is your Rx, right? They will leave and you will have the formation of RR, right? You will have the formation of double the number of your alkyl in the alkyl halides, right? Now, next important thing about this is that this is definitely a free radical mechanism, right? Next important thing about this is you will have the formation of symmetrical alkanes will be formed here. You will have the formation of very symmetrical alkanes, right? You can't have the formation of C. Propane cannot be formed from it. This is the question that they can ask you, that why propane cannot be formed from here. Because if you have CH3Cl, you have CH3, CH2Cl, you have these two things, right? There will be mixture of products that can be formed. This CH3 will combine with one CH3 to form CH3, to form CH3CH3. This CH3CH2 will combine with CH3CH2 and it will have the formation of this thing, butane. And then if this combine with this, then only it can have the formation of CH3CH2CH3. So it's not like unsymmetrical alkanes will not be formed. Yes, they can be formed. They can easily be formed from here. But the problem is there will be mixture of products that can be formed here. And we in chemistry, we hate mixture of products. We don't want mixture of products in our life. We want a simple direct method. We want, if you can give us some direct method, there is no mixture, because if you have mixture of product, then again you have to separate this out, right? We don't want to do it. We want a simple, direct, pure compound should be formed, which is not formed here. That is why unsymmetrical alkanes, very important line, write it down in your notes. Unsymmetrical alkanes will not be formed. Write down in your notes, unsymmetrical, it will form mixture of products. Mixture of products. That is the reason unsymmetrical alkanes will not be formed here. Right? Okay. Now, next thing is Wurtz-Fittig reaction. Now, Wurtz-Fittig and your Fittig reaction all are same. Just you have to visualize this thing. Wurtz is a person who loves alkanes and Fittig is a person who loves aryl halide. What is alkyl halide? Do you know what is alkyl halide? Alkyl halide is when you have a simple chain. Okay. Aryl halide is when you have benzene, right? Or benzene aromatic compounds. That is your aryl halide. So I am saying take Wurtz as your alkane loving, right? Who is like, if Wurtz is there, that means alkyl halide is there. Now it's simple Wurtz reaction, that means two alkyl halides will be there. This is your alkyl halides. That means two alkyl halides will be there. But if you have Wurtz-Fittig, that means one will be alkyl, one will be aryl, right? So here you have one alkyl and one aryl. And both of them they will say bye bye X, I want to get rid of this X, and this X will go from their life and they will join together, and this you will have the formation of a alkyl chain on the benzene ring, right? So that is the answer for your Wurtz-Fittig reaction. Okay? Yes, ma'am, tomorrow is our chemistry exam, so that is going to be very useful for you, right? So that is going to be very, very useful. Can you make all mechanisms? Students, this is not about mechanisms. Here I am just telling you the reactions, the important points here, right? Okay. Now, next is Fittig, and all the reactions are not even there in your syllabus. You don't have Fittig, you don't have mechanism of Swartz reaction, Aldol, Cannizzaro, all these are not in your syllabus, right? Some of the mechanisms are in your syllabus, not all the mechanisms are in their syllabus. Stick to only those mechanisms that are mentioned in your NCERT, right? So here you have Fittig reaction. Fittig reaction means you have aryl halides. So both are aryl halides, and here you will have the formation of, again, X will be liberated from here, and you will have the formation of diphenyl or biphenyl. Rest of the things are same here, right? Rest of the things are same here. Now, a very important test from where again the questions are asked so many times, that is your Lucas reagent. They will ask you what is firstly, so as you have seen in your PYQs itself, right, of your PUC 2 PYQs I am talking about, right. So in that, Lucas reagent has been asked so many times. That is why I have picked up these naming reactions. They ask you directly from naming reaction, and from naming reaction itself you can get so many marks, right. So just focus here, right. So everybody focus here. So this is your Lucas reagent. What is this reagent? This is anhydrous ZnCl2 and HCl. That is your Lucas reagent. So for example, they give you 1 degree, 2 degree, 3 degree alcohol. They will ask you how to distinguish between 1 degree, primary, secondary and tertiary alcohols. How you will distinguish between that? Simple, very simple. 1 degree alcohol is very boring. 3 degree alcohol is totally crazy, right? For example, there is some movie out there, 3 degree alcohol will be like, I want to go, I want to go. 1 degree alcohol is like, I don't want to go, I'm happy here, right? So 3 degree alcohol will immediately, so excited about life, immediately form the turbidity. Now, ma'am, what is this turbidity? Students, if you have a beaker, right, there is some cloudiness. For example, in water, you add some powder, right? Any powder of your choice that you use in your home, right? You add that powder in the beaker, what you will get? You will get the cloudiness. That is the turbidity that we are talking about, right? So immediately it will form turbidity. 2 degree alcohol, after 5 minutes it will form turbidity, but 1 degree alcohol, it will not form turbidity. But if you heat it, then maybe after some time it can form some cloudiness. It can show some cloudiness or turbidity. Right? Okay? Right? Very good, very good, very good. Again, that will help you. Right? So, Sandmeyer's reaction, students who have your exam maybe in coming 10 days, right? This is very, very important for you. Right? Even if you have completed your exam of midterm, right? I don't think so. But still, if you have like finished that, still this is very important for you, because this is important on the board's point of view also. Any competitive exam, this is important, right? So here you have Sandmeyer's reaction, right? That is your 8th reaction. We are at 8th reaction. Now tell me, are you able to recall all the reaction? Everybody? In the end, I'll ask you the test also. In the end, I'll ask you the test also. Now you have your Sandmeyer's reaction. Now ma'am, what is this Sandmeyer's reaction? Sand, okay, tell me, sand, sand, sand. Sand means salt. Whenever you visit a beach, there is sand. And sand is what? Sand has which thing? Sand has salt, right? Because ocean is salty. When you visit a beach, there is sand over there, right? And in beach, ocean water is salty, right? So sand is like similar to salt, right? So you can remember this by the product of Sandmeyer reaction and Gattermann reaction are completely same, right? As you can see that in Sandmeyer reaction and Gattermann reaction, you're getting the same product, that is your halobenzene, right? You're getting the same product here. But ma'am, then what is the difference? How we will remember that difference? If you're talking about sand, that means you're talking about salt, right? So first thing is, here the reagent that we will use is a salt of copper, right? That is salt of copper 1, right? It is a salt of copper 1. Here we will not use copper differently, then some other thing differently. No. In Sandmeyer's, that means we are talking about salt here. S for sand, S for salt. Here we will use the salt of copper 1 with halide, that is your CuX. And that X can be chlorine or bromine. That means either you can use CuBr or you can use CuCl. Any of this you can use here, right? Any of this you can use here. But when we talk about the Gattermann reaction, right? In Gattermann reaction, it's like a dirty place, right? A Gattermann reaction. So a Gattermann reaction is a thing which is, you can say here we will not use sand, rather it is very smelly, right? So what we will use here? Here we will use copper differently and HX differently. For example, you will use copper with HCl or copper with HBr, right? Copper with HCl and copper with HBr. It is opposite of that. You just remember about sand, and Gattermann is opposite of that. In Sandmeyer's, you have salt of copper, that is CuCl or CuBr. Product is same as Gattermann, but in Gattermann, you don't use salt. Here you will use simply copper with some HX, right? So that HX, X can be chlorine or bromine depending upon the product that you want, right? Now, next important thing here. Now students, the next important thing here, that ma'am, is this also a Sandmeyer reaction? They can ask you, what is the first step of Sandmeyer reaction? No, this is not a Sandmeyer reaction. This is a reaction where we are forming disonium chloride. What is this called? What is this called? Disonium chloride. Disonium. Where should I write it? Where should I write it? Here I should write CuCl and CuBr. And here I am writing, this is your disonium. Disonium salt, right? Okay, this, don't worry, we will study the same reaction in your amines chapter, right? That is not in your midterm, but we will study the same reaction in detail. We are going to study about this reaction, right? Here you have HCl and NaNO3, or simply directly maybe they will write HNO2. They can directly write HNO2 also, right? Because HCl and NaNO2 are going to form HNO2 only. But the temperature should be very, very cold. Temperature is important, 0 to 5 degrees Celsius. This disonium salt conversion to your halobenzene is called Sandmeyer or Gattermann reaction. But this particular is not your Sandmeyer reaction. This is not Sandmeyer reaction. This is a formation of disonium salt here, right? This is the formation of disonium salt. I hope so that is clear to you. Students, let me know in the chat box if that is clear, because I want a two-way interaction, right? I don't know how to teach when my kids are silent, okay? Don't do this to me. I love it when you interact with me. I love it when you tell me that, yes, ma'am, we are, because, you know, I know this is a YouTube thing. You must not be very, very habitual with this thing that a YouTube teacher is asking again and again, are you able to understand? But this is how I teach my kids, right? I don't want any of them to feel like I am not there, right? I want you to feel that I am sitting in your room, right? I am sitting with you and we both are talking to each other, right? That is only possible if you write it down in the chat box, because that's the only way I can see, right? It's not an offline thing that I can see, this kid is not able to understand. I can only see with your chats, right? Okay, perfect. Very good, very good, very good. Which confusion, for example, you have sand. Sand means salt, right? Sand means salt. Here you will use copper salt with halide. But if you talk about Gattermann, there is no sand you should use. Simple use, the difference is in the reagent. And why there is specific name for naming reaction? It was given by a scientist, right? A scientist properly made this reaction, right? Worked on this reaction. That is why to give them respect, we have given them a specific name. So it's not like you can convert disonium salt to halobenzene with this also, with this also. But when you use copper salt, in that case it is Sandmeyer. When you don't use copper salt, you use copper with HX, then it is called Gattermann reaction. Okay? 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 Now, next part is your Kolbe's reaction. So I hope so now you guys are clear with that, right? Very good, Arjun. So now next is your Kolbe's reaction. Now this is a very, very important reaction. Very, very important reaction, right? So guys, let us see Kolbe's reaction, right? What will happen here, what we will get, right? So basically, these are the reaction of phenols. Here you will get salicylic acid, because this is COH group, right? So here you will get salicylic acid from phenol, right? So here you will add some base here, then you will get sodium phenoxide. This is called sodium phenoxide. Sodium phenoxide. Now ma'am, how do you remember this? Na for sodium, and this ion is called phenoxide ion. This ion is called phenoxide ion, right? So from sodium, from this phenol to by adding base, what is the work of a base? To take out H positive. It will take out H positive and it will have the formation of sodium phenoxide. Then after that you will add CO2 and you will add H positive, right? And hence you will get salicylic acid, that we usually know that in most of the, if any of you face acne, have acne problem just like me, right? You guys are teenagers. I feel that you must have I don't want that you should have that problem. But I know most of the teenagers, right? They have this acne issue. So just read out in your that ingredients, right, of your face wash or anything, there will be salicylic acid, right? So that is a very, very good ingredient. If someone is facing acne prone skin, this is a very good ingredient, right? This is the same thing that we are talking about, right? So salicylic acid, right? Now, next thing is your Riemer-Tiemann reaction, or you can say Riemer-Tiemann reaction. In this same thing, we will use from phenol, we will make salicylic, this is aldehyde group. So this is called salicylic aldehyde. Salicylic aldehyde. Now, from Kolbe's, we made salicylic acid, right? Acid. Kolbe made acid, right? From your carbon dioxide and H positive. But here students usually, replace these two things between each other, right? So I don't want you to do that. Here this is Kolbe's. In Kolbe's you make salicylic acid, right? That is used for your skin, right? For your acne prone skin, right? Yes, very good. So that is for acne prone skin. You can understand this by, there was a person named Kolbe who has a lot of acne, right? A lot of acne on his face. That is why he is using this salicylic acid, right? But here, Riemer-Tiemann, Rima is a person, Rima is a girl, she don't have. Kolbe is a boy, he has a lot of acne on his face, that's why he is using salicylic acid, right? Rima is a girl, she don't have any acne, right? That is why she is not using salicylic acid, right? That is why here we have salicylic aldehyde, not acid, right? So here you have aldehyde. Now the reagents are different, the product is also different. Here the reagents were CO2 and H positive, right? But here the reagent is CHCl3 with base, and the second step you will have, that is your H positive. Now very important thing, if you talk about CHCl3, that is also called chloroform, that we use in Hindi movies, no? In movies what you use? Okay, there will be someone, I want to kidnap you, what I will do? I will put my, on my hanky, I will spray something called chloroform and I will apply this on your face. Then what the other person will be like? They will faint, right? So that you must have seen in so many movies, right? That's a very old thing that we used to see in movies. So that is the same thing. That is a chloroform, right? So chloroform is used here. Chloroform is used here, right? So chloroform with KOH and H positive at the end, because we want to make here OH, right? So this will give us salicylic acid. Now very important thing about this is, here you will have the formation of a very good intermediate, or not intermediate, I would say electrophile, that is your dichlorocarbene. Directly they can ask you in Riemer-Tiemann reaction, what is the electrophile? The electrophile. In MCQs they can ask you this thing. So write it down, it is dichlorocarbene. That is, you have 2 electrons here, this is Cl, this is Cl, this is your dichlorocarbene, right? Okay, dichlorocarbene. Everybody in your seats, I want you to also speak this. Dichlorocarbene is used in Riemer-Tiemann reaction. When you will study amines, you will also see one more reaction, that is your carbylamine reaction or isocyanide reaction, that is called. That is not in your midterm, but yes, we will see that reaction in future. Same thing will be formed. Not products will not be same, but the reagent will be same and the electrophile is same. Ditto, as it is. Same thing will be there, right? But here you don't have that thing in your midterm. So just remember, Riemer-Tiemann reaction, aldehyde is formed here, and here you have the chloroform with KOH and H positive, and here the electrophile is dichlorocarbene, right? Now important thing, why ma'am both of them are ortho? Because here this H positive and this O will have some hydrogen bonding, right? This H positive and this O will have some hydrogen bonding. Because of this hydrogen bonding, usually we have para as the major product. Here also para will be formed, but ortho is the major product. So always you will see in Riemer-Tiemann reaction or Kolbe's reaction, you will always see ortho product. Why? Because of hydrogen bonding here, it is a major product. Whenever there is hydrogen bonding, that ortho product will be the major, otherwise para is the major, right? Okay. Yes, you can definitely depend on chemistry, depend on me for chemistry. I can guarantee you that, right? I have got 99 marks when I was of your age, right? So just relax. It's not a very difficult thing. It's a very easy thing. You can trust me, not only for boards, for your KCET, for your competitive exam, right? You can definitely trust me on that, right? So just see my lectures. Eventually you will yourself feel, right, with the proof I am showing you, you have the demo classes, you will feel that okay, whatever ma'am is teaching, that was there in the exam. You can see that from the midterm also, right? Okay, so now next is Williamson synthesis reaction. Now Williamson, so how to remember this thing? There was a son of William, it feels like some foreign name, right? William. So William is some kind of person who is there to advise Roxa. He said that Roxa, don't cry, Rona. Roxa, Rona, roar, like the lion, roar. You should roar. You should not get scared of anyone, right? Roxa, you should Just eliminate X from your life, kick that X from your life, and then you should roar and you should happily live in your life, right? So that is what William is advising Roxa, that take that X out of your life and you should roar, right? You should not cry, you should roar, right? So here Rx, you have RONA, right? And you have RR. So what exactly will happen here? This is your R and this RO, they will join together. This is negative, this is positive, right? So basically this Na and this X, they will combine together to make NaX, right? Now, this reaction is very, very important. And here, no, it's not like very simple questions will be asked. They can ask you also a tough question. That is, they can ask you have Rx. Now, they can ask you primary halide. Now, what I have made, this is a trick for you guys, right? So, they can ask you, make this ester, make this ether. You have CH3, you have CH3, right? You have CH3, right? This question is your PYQ only, right? I am not making it up, right? This is your PYQ from PUC midterm, right? So, this is the question they are asking you, make the ether, right? Make this ether. Now, you have two things. Either you can use CH3X plus C, CH3, 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 ONA. Or you can use the opposite. Or you can use CH3, ONA plus CH3, wait a minute, I am drawing it here, CH3, 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 X. Now, which answer you will say is the right answer? Hello Tanuja, hello Tanuja. Yes. So now, which answer you will say is the correct answer? You will get confused here, right? This can also be, ma'am, the right answer. This can also be the right answer. And this is the question that they ask you from Williamson synthesis reaction. Now, I am saying this is not the correct answer. Rather, this is the correct answer. Why so? Why I am saying that? Because in this reaction, in this particular reaction, it is final that always use your primary halide. If you have a choice, then you should use halide as the primary. Your this RONA, right, that is your sodium alkoxide, right, this is called sodium alkoxide. This can have anything. This can be your allyl, this can be aryl, this can be 2 degree, 3 degree. But if you have a choice, you should give halide as the primary, right? So you will not choose this as the right answer, rather you will choose this as the right answer, right? And hence this will be your correct answer. Yes, students? So that will be your correct answer here, right? So now coming to the next question. Next is your Etard's reaction. A direct reaction is there. Now in this direct reaction, right, the reagents are very important. Here I am going to talk about two reactions. One is Etard reaction, one is Gattermann-Koch reaction. See why I have collectively taken same kind of reactions here. Etard reaction and Gattermann-Koch reaction both are forming benzyl aldehyde. That is, on benzene you have CHO. In Gattermann-Koch also on benzene you have CHO. But Etard reaction, we are forming the benzyl aldehyde from toluene. This is called toluene. When you have CH3 on benzene, the name is toluene, right? The name is toluene, right? So from toluene you are making benzaldehyde, right? This is from toluene you are making benzaldehyde. Now tell me one thing, what are the reagents? You don't have to remember this. You don't have to remember this. Just directly remember, from toluene to benzaldehyde you have the reagent, that is your chromyl chloride. This is called chromyl. This is red in color. Chromyl chloride, right? If you don't want to, you don't need to remember the color. Just remember the chromyl chloride. That is the name of the reagent. In presence of carbon disulfide, that is a non-polar solvent, that is CS2, right? From here you are making benzaldehyde. In Etard reaction, right? Etard and Gattermann-Koch, same answer is there, benzaldehyde. In Etard you have toluene, right? In Etard you have toluene, ET, you can remember Etard. You can remember from this, Etard, right? Etard. E means Etard, right? Etard, from the name itself you can see T is there. So that means toluene you have to make from here, right? Simply from the name itself, Etard, Etard. So you can see in Etard and Gattermann-Koch reaction, both are making benzaldehyde, right? Both are making benzaldehyde. But in Etard reaction, the second is T. So T means from toluene you have to make benzaldehyde here, right? From toluene, right? Again, I am saying from toluene. But in this thing, there is, again, from the name itself, I will tell you what is the answer. You have Koch. So here, can I write KOCH as CHO? So here you can see that CHO is formed. CHO, that is benzaldehyde, is formed. So how can I make benzaldehyde? So this is same as Friedel-Crafts acylation reaction. In Friedel-Crafts acylation reaction, you have this as the electrophile, right? So you will use any of this alkyl chain can be there, and you will use this in presence of anhydrous AlClC. Do you remember Friedel-Crafts acylation? Very simple, right? So you form an electrophile. Here, I want an electrophile that is my HC double bond O positive. Only then I can attach this electrophile over here. That is my aldehyde group. That is my aldehyde group. CHO is my aldehyde group. Right? This is a way so that you are able to understand things, what is happening here. So that you are able to relate things. Right? In this way, you will never forget this reaction. Because I know all of you remember Friedel-Crafts acylation. You forget Gattermann-Koch reaction. This is the problem. So I will relate these two things because actually they are relatable to each other. So this CHO, in your Friedel-Crafts acylation, you have RCO. There is a chain. But I don't want any chain here. I want hydrogen here. This is your formyl chloride. This is not a stable compound. That is why we are not using it here, right? That is why we are not using it here. Then how to make it, right? We want this thing. We want this thing, right? How to make this thing? From here, you can just replace. You can just take out this thing. This is the best way to remember, right? Take CO from here, CO. Take HCl from here, HCl. Right, and rest of the thing is same as Friedel-Crafts acylation, that is your anhydrous AlCl3. Do you have to remember this? What was Friedel-Crafts acylation, ma'am? We have one R, then we have C double bond O, then we have C double bond O Cl with anhydrous AlCl3. I am saying in this CHO group, you don't need RCO, you need HCO. You need HCO. So that means this is needed. So what you do? Take this CO, take this, you have HCl and anhydrous AlCl3, so you have only in Friedel-Crafts, right? So this is done. Now tell me, are you able to, remember things? I think this will make the things very easy to remember, right? Okay. Ma'am, should we by heart this reaction? Yes, you have to remember these reactions, right? That is why I am making up stories for you. That is why I am here. Right? Otherwise, so you could have just done this from the book, right? I know it is difficult to remember things. That is why I'm standing here. So I'm repeating things again and again so that you're able to, by heart, you can just remember this in the exam that, okay, this was the ma'am told us that CO plus HCl and anhydrous AlCl3. You'll be able to recall things more easily in the exam, right? Okay? Okay, students, now, yes. Now, next is Clemenzin reduction, right? Now, students, we have done benzaldehyde. Okay, tell me in the chat box. First was, everybody, I am revising all the reactions that we have done till now, right? I am revising all the reaction in fast forward speed. Finkelstein and Schwartz was your halogen exchange reaction. In Finn, there was no fashion, iodine, right? Roxa was using nail paint, NaI. But in Swati said that wear some gold chain, some silver chain, wear something and get that fashion, right? That's why now Roxa is fashionable, right? Next is your Darzens reaction. Simple. When Darzens drank alcohol, he felt that I should get some soda to take that OH out of my head, right? So he drank some soda, SODA, soda. That means SOCl2, and he take out that OH from his head, and now it is RCl. Next is your Wurtz reaction, Wurtz Fittig and Fittig reaction. All three are similar to each other. You will double up the number of alkyl chain. This RX will become RR. If you have Wurtz and Fittig, Wurtz means alkyl, Fittig means aryl, right? Now, if you have Fittig, that means both of them should be aryl. right? Next is Lucas reagent to distinguish 1 degree, 2 degree, 3 degree alcohol. Then you have Sandmeyer. Sand means salt. That means salt of copper will be there, and you will have the formation of, in Sandmeyer and Gattermann, you will have the formation of halobenzene, right? Sandmeyer you will use salt, and in Gattermann you will use copper with HX, right? Next is your Kolbe reaction and Riemer-Tiemann reaction. The pair is Kolbe and Riemer-Tiemann. Kolbe is forming, from phenol it is forming salicylic acid, that is useful for our acne, right? But your Riemer-Tiemann reaction, that is forming your salicylic aldehyde from your phenol, right? Wait a minute, yeah. So now here you have the formation of CHCl3, KOH, right? And these are the reagent, and hence you have the formation of aldehyde here. Williamson synthesis is a different reaction. It is not paired up with anything. Here you have the formation of ether. Just remember, here you should use 1 degree halide, right? Then Etard and Gattermann-Koch are same when you have the formation of benzaldehyde. ET, T means toluene. Here from toluene you will make a benzaldehyde with the reagent, that is chromyl chloride and CS2. Gattermann-Koch means KOCH. That means CHO. Again, benzaldehyde will be formed from which thing? Your CO, HCl and anhydrous AlCl3. This I have told you the direct tricks for that, right? Next is, few reactions are left. We are almost done with it. Next is your Clemmensen reduction. Now, Clemmensen and Wolff-Kirschner are similar to each other, right? In both the cases, you will reduce. What is reduction? Reduction is addition of hydrogen. So, you will take out this double bond O and you will add HH over there, right? What is reduction? That is addition of hydrogen. So, instead of this double bond O, you will have 2 hydrogens here. In Clemmensen also, in Wolff-Kirschner also, same product, same reactant. Everything is same. Same reactant, same product. The difference is in the reagents. So here what you can remember, that Clemmensen Sun. So there is a war between Clemmensen Sun. So Clemens Sun has some war between them. When there is a condition of war, that means there is acidic thing. Okay, that is an acidic thing. And here the war was in Germany, right? The war was in Germany. Germany means ZN. The war was in Germany, right? In Germany, some war happened, right? In Clemmensen, between Clemmensen Sun, and hence because of the war, this got reduced, right? This got reduced to CHO, right? This got reduced to CHO. Remember, in this Clemmensen war happened in Germany. ZnHg, zinc amalgam, in acidic condition. That is why I am saying war. War means acid thing. War is a bad thing. Acid is also bad thing, right? So acidic condition, this war happened. Now acidic condition is important here, right? This you can remember by Germany. I am writing down the how to remember these things, right? Next is your Wolff-Kirschner reduction. This you can remember by Lord Krishna, right? By Lord Krishna you can remember this, that here what was the thing? There was this CO. We told CO that you should go to Lord Krishna. He said no. He said no, I don't want to go. Then what happened, right? He was not able to heal from the depression, right? So that is why he got reduced, right? He got reduced because he said no, I don't want to go to any temple, anything, I don't want to go, right? So that is why we were saying that you should go to Lord Krishna, because we wanted them to feel basic. Basic means good. Basic means good. We said that, okay, are you feeling depressed? What you should do? You should get some positivity from Lord Krishna. Then this said no, that is why it got reduced, right? That is why it got reduced, right? Next is your Dow's process. Now, what is this Dow's process? Now, one more question has been asked from Dow's process, that is this difficult to break this bond? Yes, this is very difficult to break this bond. Why? This question I have taught you in your most repeated questions, right? 2 videos I have made on HOTS and most repeated questions, right? You can go through that. I have already answered this. Why this bond is very difficult to break, right? Now, as this bond is very difficult to break, that is the reason we have such a high temperature, 623 Kelvin. it is more than, it is about 300 degrees Celsius, which is a very high temperature, and 300 atmospheric, right? So the pressure is also very high, the temperature is also very high. In that amount of high temperature and pressure, I am able to replace this Cl with OH. But it needs a very high temperature and a very high pressure, right? Tell me, students, you can find that on my Telegram channel, Diksha Kaushal Chemistry Official, right? Okay. By the way, I am going to take up after your midterms, I am going to make you revise all the chapters in detail, right? I'll take up all the one-shots, right? Now, next is your Aldol condensation and Cannizzaro reaction. Now, just remember this, a simple trick I will give you. From that trick only, you will be able to understand simply, right? So, let us talk about that trick. First thing is, in Aldol condensation, what you will have? Dilute NaOH, base you will use. Important thing is, write it down here, you should have alpha hydrogen here, right? If you have alpha hydrogen, then aldol condensation can take place, right? How it will take place? One thing I have already written here, how you will write this thing. For example, any aldehyde or ketone is given to you, right? So what is your alpha carbon? This is your alpha carbon, right? This is your alpha carbon over here, right? So what you do, open the CHO group of one molecule and don't open the CHO group of other molecule. Instead, open the alpha hydrogen of the other molecule. In one molecule, this is the same molecule. I have opened up CHO group. In other molecule, I have opened up the alpha hydrogen. This is the same molecule. Just the way of writing it is different. Now, are you able to see this? This is the same molecule. CHO, CH3, CHO, CH3, same molecule. Just the way of writing it is different, right? Okay. So now, here it is. Here, as you can see, this is your alpha hydrogen, right? This is your CHO. How you will answer it? Firstly, you will write this as it is. You will write this as it is, CH3, C, double bond OH. Now, what you will do? You will break this double bond, right? And this will be your negative, right? And this will be your positive. Isn't it? You will break this double bond. Oxygen is more electronegative. It will be negative. It will be positive, right? Now, this CH, this alpha hydrogen, right? Because alpha hydrogens are very acidic in nature. Why we are always focusing in organic chemistry? We are focusing on alpha hydrogen, because they are very acidic in nature, right? So, H positive will be eliminated and this electron will jump on this side. This I am giving you the total mechanism, but if you want to write it down directly, how you can write down directly? Just write down CH3, C. Instead of this O, just flip this H to this side, right? So I will write H here, and to this carbon, attach this carbon. So it will be CH2, CHO. Rest of the things will be same. Are you able to understand what I just did? I'll do that again, because this is a very, this is a very hot question that they can ask you, right? So here this is your CH3, right? This is your C, this O, and this hydrogen will be shifted here, right? This carbon, the alpha carbon, just remember, the alpha carbon will be connected to the carbonyl carbon. Connect the alpha carbon to the carbonyl carbon. Write it here. Connect alpha carbon to carbonyl carbon. Carbonyl carbon. You have to connect this carbonyl carbon to alpha carbon. So it will be CH, it will be CH2, and this is your CHO. So that will become your full equation, right? Okay, that will become your full equation. Next is your Cannizzaro reaction. Right? Next is your Cannizzaro reaction. In Cannizzaro reaction, what you have to do? Again, very simple. Here you will have concentrated H in NaOH and there will be no alpha hydrogen. There will be no alpha hydrogen here. If there is no alpha, the trick is only no alpha hydrogen is present. No alpha hydrogen is present here. That is why simply, very simple. One will be reduced and one molecule will be oxidized. How, ma'am? If you reduce aldehyde or any ketone, you will reduce it to alcohol. One will be alcohol, other will be your carboxylic acid. Carboxylic acid salt. Carboxylic acid salt. Right? So here with the same number of carbon, if you have one carbon and the OH group you have to make. So that will be CH2OH. If you have one carbon and acid you have to make. So that will be HCOOH. But I want to make the salt here. So it will be Na. So it is CH2OH and HCONa. Right? So you will have in Cannizzaro reaction, one product is your alcohol, other product is your carboxylic acid salt with the same number of carbon. If there is one carbon here, here also one carbon, here also one carbon. Right? Okay, students? Okay. Now again, most repeated question, Hell-Vohal-Zelensky reaction, your HVZ. Very simple, reagent is important. Reagent is your Br2 in presence of PBr3. You have H2O, that is the second step. Right? So now what will be formed here? Okay? Which thing will be formed here? Very simple thing. Everybody, very simple thing will be formed here. Just see what is the alpha carbon. This is your alpha carbon. The carbon that is next to the main thing. This is your main group. The carbon that is next to the main group, that is your alpha carbon. So just replace one alpha hydrogen with this bromine. That is your HVZ. Very simple. You have to replace this alpha hydrogen with that bromine or chlorine. If you have added Cl2 here, then you will replace it by Cl2. They can ask you how you can make alpha monochloro compound. How you can make by HVZ Zelensky, that is Hell-Vohal-Zelensky reaction. Right? Very simple. Alpha hydrogen, just replace it by the halogen. Right? Just replace it by the halogen. Next is your Rosenmund reduction. And I think last two reactions we have Rosenmund reduction and your Stephan reduction. Now, what is a Rosenmund reduction and what is a Stephan reduction? In a Rosenmund reduction, you use Lindlar's catalyst. Okay, this is basically your Lindlar's catalyst. Lindlar's catalyst. So, in this catalyst, we basically what we do, we use a compound, we use a reagent which can cause a reduction. Right, that is why we are using H2 we are using for the reduction part, H2 with your PDBSO4. Now, ma'am, what is this PDBSO4? These are your poisons. These are basically negative catalysts that will not cause that much of reduction. They will cause only that amount of reduction which can, see, we don't want this group to get reduced. We want just this Cl to get converted to hydrogen. Right? That is why it's not like you will use this catalyst for the conversion of this double bond O also into H and H. Right? So that is why you want a poisoned catalyst which should stop the reduction to this condition where you have the aldehyde group. Right? So here COCl is converted to COH with a poisoned catalyst, that is called poisoned by BSO4 or quinoline or CO3. Usually in your syllabus they will ask you BSO4 or they can say poisoned by sulfur. Anything they can write. Okay. Last reaction of today, that is your Stephan reduction. Stephan reduction is also very simple. So basically you have the formation of CHO, but here you have nitrile group. So this nitrile group, that is your RC triple bond N, will be converted. No mechanism, nothing is there in your syllabus. Right? So you have RCN is directly converted to RCHO. Right? This is converted to RC double bond OH. And here you will use SnCl2 with HCl. Okay. So you can remember this by S for Stephan, S for SnCl2. Okay. And then you can replace this RCN by RCHO. That is your last reaction. If you ask me which of the following reactions are important, all of these reactions are important for you. I won't say any of this reaction is less important as compared to other. Aldol condensation, Cannizzaro reaction, they are directly asked, HVZ reaction, all the Finkelstein, Wurtz, Gattermann-Koch, all these reactions that we have done here, all these reactions, right? All these reactions, all these reactions, right? They are all very important for you, right? I even added Dow's process here, right? Because that was also very important for you. I have not skipped any reaction here, right? Okay. HVZ, ma'am, again, chalo, I'll tell you what is HVZ reaction. It's a very simple reaction. So basically what you will do here, you have the alpha hydrogen, right? Whenever you have a main group, the carbon that is attached to that main group is called alpha. For example, I'm talking about this is your C double bond, or this is C, this is C. This is my alpha, this is my beta, right? And the hydrogen attached to this alpha is called alpha hydrogen. So here you will replace this alpha hydrogen with that halogen that you have added. Here I have added Br2 and PBr3. That means Br I have. So Br will replace the alpha hydrogen. That will be your product, right? Okay. Yes. Yes, I have a class tomorrow. Don't worry. I'll inform you on the Telegram channel. Okay. I'll inform you on the Telegram channel. Right? Okay. Yes. Okay. That we will see. That we will see. Definitely we will see that. Okay. Okay, students, then bye-bye. Take care. I hope you really liked the session. And if you want to see more of such sessions where we can take up the physical formulas, we can take other things also, right? So I want all of you to share this, right, on your WhatsApp, share this on your maybe Instagram, anywhere you can share this. You have my Instagram ID, that is Diksha__Kaushal. You can tag me on your Instagram, right? You can share the screenshot of the notes. You can share what is the best part of today's lecture, right? And you can also talk to me on my Telegram channel, that is Diksha Kaushal Chemistry Official, and also subscribe to our official Telegram channel that will be mentioned in our description, right? So subscribe to that, because all the notes, everything will be available on the Telegram channel itself. Now I'll be taking top 100 MCQs tomorrow, right? So I want all of you to join tomorrow. I'll mention the time. Yeah, it is 7 p.m. right? So 7 p.m. only I'll get live tomorrow for your MCQs part. So I want all of you to be there and answer A, B, C, D, A, B, C, D, A, B, C, D. What is the right answer? Challenge yourself and see, are you able to answer it? And I will definitely explain the questions as well. It's not like I will just show you this is A, this is B, this is C. Today also in naming reaction, I have not done like, okay, this is your reaction, you cram this. I have given you proper reasoning for that, and I have also given you tricks to remember that reaction, right? So that's also I'll do tomorrow, right? MCQs, we will see the explanations also, but I want you guys to be there in the live session so that we can interact. And with the same energy, I want all of you to be there in tomorrow's session as well. Okay, and when is your chemistry exam, and what you want me to do, other things, and everything that you find in chemistry difficult, I want it to be there, because I go through your comments, whether it's my HOTS video comment, whether it's my live comment, whether it's my short comments that I have uploaded on naming reaction. I have gone through all of that. That is why I have come up with this lecture, because I saw so many comments waiting for my naming reaction. That is why this reaction I have made for you. Now the notes will be there on the Telegram channel, and I will see you tomorrow for this same. Okay, I am also super duper excited for the same. Yes, okay, bye bye, take care, see you all in tomorrow's lecture at 7 p.m. for your MCQs part of chemistry midterm. Bye bye, take care.